I learned how to build AI agents for you. I've spent hundreds of hours building AI agents, so in this video I'm going to attempt to distill down everything that I've learned to give you a comprehensive guide with frameworks and a variety of different tools to build any type of agent you want. Whether you're someone who doesn't know how to code and wants to stick with the no-code tools, or you're a seasoned software engineer looking to build your next AI startup. I'll also be walking through real examples of AI agents built using different tools, adding useful assessments throughout this video to help retain your information as we go through things. Now, without further ado, let's get started. This is the exact structure of the video. First, I'm going to list the crucial components that make up an AI agent, what they are, what category they are in, and how to choose the best tool for the job. Next, we are going to dive deep and talk about the common agentic workflows being used today. I'll also include a crash course on prompt engineering for agents because the prompt is the foundation of the agent. Next, I will walk through full examples of applying your agent using no-code and full-code tools as well. But what is the use of building these AI agents if they don't actually serve a purpose? This is why the following steps will be figuring out what kind of AI agent to build based on your startup or business, and tech suggestions specifically for what to build. The advancement of voice, video, and image agents now enable wide use cases. We can start by defining what an AI agent is. An AI agent is a system that perceives its environment, processes information, and autonomously takes action to achieve specific goals. In a human format, we tend to think of AI agents as an AI companion to a human role or a task that a human performs. That's why you often hear AI agents in the example of a coding AI agent like Cursor or Windsurf that are AI-powered code editors that have an agent mode that can autonomously perform coding tasks using Claude Sonnet 3.7 or Gemini 2.5 Pro. Another way AI is commonly used are customer service chatbots. Many companies are testing customer service agents that are able to handle inquiries, communicate with the customer, file customer complaints, or resolve specific issues. This is a technical form of an AI agent, but when it comes to applying, there are tons of ways to implement an AI agent and lots of nuances as well. I'll give you a glimpse of what I mean now, but I'll be going into more detail later when I go into the exact implementation of agents. But now, just note that when we are talking about AI agents, we don't mean an AI agent just chilling doing its AI agent thing alone. Usually a group of sub-agents are doing individual work that eventually combines to complete a large goal. The group together is what we perceive as the actual AI agent. An example would be the classic AI service agent that is commonly split into a sub-agent that handles customer questions and interacts with customers, determines the issue, then hands off the information to a more specialized AI agent. For example, a reported problem with billing would be tagged as a billing payment issue, then passed along to another sub-agent that is tasked only with billing and payments. Other agents are tasked with IT, sales, or other services required by the company. This type of workflow would be considered routing and has been proven to be great at this problem. Don't worry, we'll go into these type of routing and workflows soon. But I do hope that this gives a general understanding about how AI agents work below the surface, which is super important to know as we build them. Also, I wanted to answer this question you might have about why do we have these multi-agent system implementations. The reason will make sense if you think about how humans work. On a team, each player has different roles. You don't want each player taking multiple roles because they can easily get confused and not focus on what they are doing or specializing in a specific task. It is the same for agents. When we have individual agents, the results are stronger than one agent that does everything alone. Now I'll take a moment to give you the framework to understand the components of AI agents. Kind of like making a burger is made of different components. There is a bun, patty, lettuce, and toppings. You can change the type of bun, type of lettuce, type of patty, and type of condiments, but you do need all of these to make your burger remain a burger instead of a sandwich or a glizzy. Same with agents. You can switch out the components, but you will need a form of those components to make an agent. Unlike the long-standing burger components, AI agent components are pretty new. People have different definitions, but OpenAI has the most universally used. OpenAI states building agents involves assembling components across several domains, such as models, tools, knowledge and memory, audio and speech, guardrails, and orchestration. And OpenAI provides compatible primitives for each. As expected, OpenAI would list its own tools, but there is a range of alternatives as well. Based on the type of agent you want to create, some are better, some are worse. Before I break down each individual component, I want to note that you can easily feel overwhelmed by the amount of new tools that are being released. But don't worry. Whatever new tool that comes out to reinvent AI agents will always be a part of this framework. It's like a new ingredient for your favorite burger. Might have a unique flavor, but it won't change everything. I hope that this makes sense and it doesn't sound too weird. Okay, now let's move on to the components. OpenAI has this amazing table. So first you have the model components. These are your AI models, your large language models that are the core intelligence capable of reasoning, making decisions, and processing different modularities. OpenAI examples are the o1, o3 mini, GPT 4.5, GPT 4o, and etc. The model you will use is decided by what you are building. In OpenAI, GPT 4o is the flagship model. It is great at reasoning, multi-step problem solving, and complex decision making. GPT 4o can be considered a thinking model. GPT 4.5 is more expensive and slower, but it also answers with more depth, good for writing and making new ideas. o3 mini is faster and has advanced reasoning capabilities. Besides OpenAI, Claude Sonnet is the current king for coding, reasoning, and technology work in general, but Gemini 2.5 Pro is moving up the ranks fast. Overall though, the ranks do change often, so keep an eye out for what's new. If you want to save money, go for an open source model and host it yourself. If you want speed, go for a smaller model. Most Google models currently have high context windows. If you ever want to check out the current rankings, there are sites that rank these models like Vellum you can use to stay updated. Tools are an important component that should not be overlooked. Your model is just a base, but adding different capabilities like tools can often be a game changer. Tools let agents interact with the world, like searching the web for example. All the applications you see in the world can potentially be converted into tools for the AI to use. It can connect to Google products like Gmail, Google Calendar, local files on hard drive. It can connect to your screen, other apps like Slack, Discord, or even YouTube, and a ton of other apps as well. You can even build your own custom tools to use with the AI agent. You will need to have coding skills to use OpenAI's SDK, but with some skill, you can use it to create your own tools, or use the built-in tools like web search, file search, and computer use. Another cool thing is Model Context Protocol, or MCP for short. MCP is a protocol that provides a universal way to provide tools to your large language model. This is a major feat because in the past it was difficult for developers to provide agent tools since software can configure in a variety of different ways. Before MCP, developers would usually need to figure that out alone. But if you're not a coder, don't worry. There is a ton of low or no code tools that are embedded with the ability to apply tools to your models. I'll show some examples later, like n8n that allows you to drop different tools into your large language model. For example, if you're building a large research agent, it'll need an internet search tool, a data analysis tool, and maybe a tool to email reports. Okay, so next is knowledge and memory. Knowledge and memory uses two types. First is knowledge-based or static memory. This can give your model static facts or documents or any information that will not change over time. This is great for a law firm related AI agent that may need to analyze legal documents for a case or in general to manage records and policy documents for a business. The other type of memory is persistent memory. This memory can track conversation history or user interaction beyond more than one session. This is revolutionary for creating chatbots and allows them to remember what happened in past conversation. OpenAI provides its own file storage like vector stores, file searches, and embeddings, but you can always use open source options where you host your own database and you can create your own form of retrieval augmented generation, or RAG for short. Don't want to go too deep on this, but some options are Pinecone, which is cognitive and built for vector search, or Weaviate, which is open source. If you use no-code solutions, this won't be a factor because they'll already be built in. Like n8n sets it up so you can completely avoid coding for RAG and databases. Next is audio and speech. Most frameworks don't have this in a separate category, but OpenAI does because of how much innovation has taken place recently. Giving your agent audio and speech allows it to interact with natural language. This is great for chatbots because being able to use spoken language can greatly increase the experience. OpenAI has its own implementation, but outside of that, 11 Labs has been very popular for voice cloning and generation. And for audio to text, people have been using Whisper, which is an OpenAI model. This is true today, but things often change in this space, so it is always a good practice to keep updated on what's new, while understanding the core concepts as well. Next up is guardrails. Guardrails are needed to prevent undesirable, harmful, or irrelevant behavior. When you make your agent, you need to make sure it does not do anything it shouldn't do. When you create a chatbot for customers, you want to make sure it doesn't try to become the next great poet or anything weird like that. Outside of the OpenAI system, Guardrails AI is used a lot, but there is a good amount of options for this category. But again, if you are using no-code tools, it is important to understand the concept, but most of the tools have guardrail solutions already built in. Last but not least, we have orchestration, and this can easily go unnoticed. Orchestration is how we combine sub-agents like I mentioned before. It also allows deploying to production, monitoring, and improving an agent. Like when you deploy the agent, you don't just let it roam free, you need to make sure it functions like expected. Also, updates happen all the time, so it is important to keep monitoring and make sure that the agent is working like it should. There's a lot of different tools in this category. Usually there is a framework that the orchestration part is built in. OpenAI has a system. There is also Crew AI that is a framework for multi-agent systems that uses its own system for orchestration and deploying. LangChain is used a lot for deploying and managing agent interactions. And also Llama Agent, which is great if your agent deals with documents, knowledge bases, and static memory. This is a cool mnemonic to remember the different components of an AI agent, which you can test now while we do our first AI assessment. I'll put some questions on screen now. Comment below your answers to make sure that you have retained all the information we just went through. Now that we have broken down the components of an AI agent, let's move on to the implementation. Like I mentioned before, AI agents are not usually a single entity, but a group of sub-agents that combine to accomplish a goal. An amazing resource that covers common agentic workflows and agent systems is the Building Effective Agent Guide from Anthropic. Let's take a deeper look into this. Starting off, you have the augmented LLM, which is the basic building blocks of agentic systems. You have the input, LLM, then the output. The LLM can generate their own search queries, select the appropriate tools, and decide what knowledge should be retained to memory. You may notice the similarities between these components and OpenAI components. This version is simplified and does not reference guardrails or orchestration, but you can definitely notice the overlap. That's cool. Just know when it comes to testing or deploying, the OpenAI components are still at play. Also note that these augmented building blocks are usually referred to as sub-agents as well. Alright, so now let's see how these sub-agents combine to form what you might call a super agent. We'll start with the basic workflows and build up to more complex workflows that are truly autonomous. The simple agentic workflow is called prompt chaining. Prompt chaining decomposes a task into a sequence of steps where each sub-agent processes the output from the previous one. Basically, this works like an assembly line. You can add a gate that can fork into different routes, but the logic is the same. You have the input, the sub-agent interacts with that input and passes it down the line until you finally get the output. This integration is great when your task can be segmented into subtasks and decomposed. A use case for this would be if you wanted your agent to create a report. The input could be information user requested. The agent can then take that and create an outline, pass it down to another agent that evaluates the outline for specific information, then pass it to the agent that will write the report out, then to an editor agent that tweaks and polishes the writing. Then the final output is the requested user information. Another workflow type is routing. In routing, you have user input that the agent directs into one of many potential follow-up tasks. Each task is managed by a separate sub-agent specific to that skill. Then finally, the user receives the output. Routing works great for complex work that has separate objectives that can be handled individually. A great example is a customer service bot. The service bot can receive different objectives like general questions, refund requests, tech support, or whatever else is requested. Based on the type of request, the first sub-agent will be handing off to the best following agent for the job. A refund request would go to the sub-agent created to help with refunds, just like a tech support request would go to the agent built for tech support. Another way routing is used would be sending different questions to different types of models. Some models are more capable than others for a job. A STEM-related question is greater for Claude Sonnet 3.7, A simple question that needs a quick response should go to Gemini Flash. Next workflow is parallelization. Definitely not a tongue twister. Parallelization has two core variations. This involves sub-agents working simultaneously on a task. Then all the outputs are combined together. The first part is sectioning, which is breaking a task into independent subtasks that run parallel. Second part is voting, which is running the same task multiple times to get a range of output that are then combined together. An example of sectioning would be if you are evaluating the performance of a new model. Each sub-agent can test a different aspect of the submodel. One can evaluate speed, another can evaluate accuracy, and many other aspects as well. An example of voting is reviewing a piece of code for vulnerabilities. You have different sub-agents testing the code. That data is eventually combined to vote if a vulnerability exists. Building on complexity, the next workflow is the orchestrator worker. This workflow looks a lot like parallelization. The difference being it does not use a predetermined list of subtasks to complete. This is great for complex problems where you don't need to know the exact subtask needed. An example would be building a coding agent. Usually you don't know the exact requirements of the code you need to create, so you need the ability to dynamically change the process. Another example is a searching task that can require an unpredictable range of different information using different sources. Increasing complexity, next we have evaluator optimizer workflow. Definitely a more autonomous workflow where you give the sub-agent a lot more leeway in determining what it should do. You provide input, then the first sub-agent attempts to generate a solution. That potential solution is passed to an evaluator sub-agent. The evaluator may send the solution back with notes if it doesn't meet expectation, creating a loop that will continue until the solution is valid. When the solution is good enough, the evaluator will pass on the solution to output. This workflow is great when you have a clear evaluation criteria and when you can see improvement over time. A use case would be if you are translating something into a different language. There may be context issues that cause mistakes in the first translation, so the evaluator will request more iterations until it finally meets the expectation. Another example is if you have complicated research that should be written into a document. The first research may not be good enough, so the evaluator will provide notes and suggestions until it does look good enough to output. Last, we have the truly autonomous agent. This one is interesting because the implementation is the easiest, but the results have the widest range of potential outcome. This flow begins with human input that is followed by 100% agent independence. It will perform some form of action that will result in a change to the environment. The agent then self-determines what the result is based on that environment. Like if it searches for information or uses a tool to accomplish a goal, it is self-guided in finding the solution to the request. This self-evaluation loop is repeated until it feels that the task has been completed. This workflow is frequently used with open-ended problems that are difficult to determine the best steps forward. You're really just throwing a request out to the agent and then it takes the request and uses its best judgment. The results of this workflow can be really amazing and inventive or completely trash and useless. Some examples from Anthropic are a coding agent that can resolve different developer bench tasks that involve editing a large amount of files on a task description, or their computer use implementation, where Claude was given complete access to a computer and used it to complete a task. This diagram represents the path coding AI goes to accomplish goals. Notice a good amount of back and forth between the environments, refining the data before being output to the user. You should know this workflow is not generally what you would want to use because in most cases you can use a more specific agentic workflow that gives more accurate results and saves you money as well. The best practice is to use the most basic workflow you can. If you can get the work done with prompt chaining or routing, don't make it hard for yourself with unneeded complexity. Kind of a golden rule when using AI agents or working with technology in general. If it ain't broke, don't fix it. Okay, so that was the workflow breakdown. Next, let's do a mini prompt engineering bootcamp. When working with an AI agent, prompt engineering is the web that keeps things together. Prompt engineering is very important. You can have the best agent with the best tools, but without a good prompt, things just won't flow correctly. When you work with an AI agent, the prompt needs to be 100% complete from the start. We don't have the option to change the prompt throughout the process. These are the 6 components you should consider including with your AI agent prompt. First, we have the role. This is when you tell the agent its job title, like web developer or research assistant, but you also want to include the expected vibe or personality of the agent. An example would be, you are an AI research agent tasked with summarizing the latest news in artificial intelligence. Your style is succinct, direct, and focused on essential information. Next component is task. You can add, given a search term related to AI news, perform a web search to retrieve information from the past week and produce a concise summary of key points. Next is input, where you tell the AI what it will receive. This is an example I added, a specific AI related search term provided by the user. But if you were using things like graphs or specific documents, you would want to note those in the input as well. The following component is output. This lets the AI know what you want it to generate from the input data. What should it look like? What is the final deliverable? The example used states, provide only a succinct, information-dense summary capturing the essence of recent AI-related news relevant to the search term. The summary must be concise, approximately 2 to 3 short paragraphs totaling no more than 300 words. Now the AI has an accurate target to aim for. The fifth component is constraints. This is super important to tell your AI what to do and not to do. I used, focus on capturing the main points succinctly. Complete sentences and perfect grammar are unnecessary. Ignore fluff, background information, and commentary. Don't include your own analysis or opinions. Last, we have capabilities and reminders. This is where we tell the agent what tools it has and point out important points to touch on. An example for an agent using a web search tool would be, you have access to the web search tool to find and retrieve recent news articles relevant to the search term. We also need to remind the AI of the date. A lot of models don't know the actual date or time, so make sure to note that in the prompt because we only want information relevant to this time period. We can add, you must be deeply aware of the current date to ensure the relevance of news, summarizing only information published in the last 7 days. A rule of thumb is the more important the prompt component, the lower on the prompt you want it to be added. This is because of the way models process the prompt. The more recent information is given more priority. This was the prompt engineering bootcamp. Might not seem that important, but I have seen horror stories written by the guys who glossed over the aspects of building agents. Always best practice to establish a solid foundation. Bad feeling working on a broken agent with no idea how to fix it. Now you have the skills to create your agent, but also the confidence to move with a purpose. Here's quiz 2. Make sure to answer these in the comment section to be sure the information is being retained. Now we get to the fun part. I will be showing you the actual implementation of AI agents. I included a range of examples from no code and low code all the way to full code as well, so everybody should get something from this. This is a customer support agent created using n8n. n8n is a no code, low code platform that is really easy to use. It's great for creating all type of AI agents. In this example, we use a multi-agent system with the routing workflow we spoke about before. It starts with the customer sending an email inquiry. The email goes to an OpenAI text classifier that routes to either tech support, billing, or general inquiry, each utilizing their own workflow. Let's dive deeper on this. I'll note refund in the subject, and I'll let it know I need my refund. Once that is received, the email is classified as billing and sent to the sub-agent. The agent then sends a response email. The response email has some basic formalities and requests that you provide more information. A technical support email will use a different workflow that attempts to search documentation for a solution to the problem. If a solution is not found in the documentation, the agent will escalate with a Discord message like this. Hello team, customer needs help. Please investigate further. The email ID will also be listed for reference so a real person can follow up with the user. That portion is important because you always want a way to escalate to a real person. For a general question, it goes to a simple path and replies with a general email asking for more information. In the next example, we have an AI news aggregator. It is set for 7 a.m. daily to go gather news from a range of sources, combine the information together, and provide a summary to the user with WhatsApp. This shows the parallelization workflow in practice. I'll run the agent now so we can see the result. I also want to note that n8n is limited to run sequentially, even with the parallel workflow. If we use the OpenAI SDK, which I'll show later, it will be running parallel, but n8n just doesn't have the ability. Now the agent sends a WhatsApp message with news from the requested sources, information about GPT-5, AI ethics, and other related information. Notice in the prompt I requested the agent cite the sources, so if I want to look further into any article, I have the option. This agent is legendary because I can tell it exactly what I need to know, how I want it broken down, and how I want everything grouped together. Super useful tool if you need daily news updates. Now let's check out a daily expense tracker with dual input. How it works is you add the input through WhatsApp, send it pictures or receipts of your spending, maybe even a text message saying, hey, I spent $10 today. Every day it processes all that information to create an expense track report. It stores the report on Google Sheets and sends you a copy via WhatsApp. For example, I spent $10 on a potato. $10 on a potato is crazy. But it adds this information to the expense tracker. You can see the other added expenses here and sends a report on WhatsApp with a cool little breakdown. Based on my previous example of spending $4,000 on steak and chocolate, it probably thinks I'm on an episode of White Lotus or something. Regardless, this is a great build for tracking a budget. So from the workflows we discussed earlier, what agentic workflow do you think the daily expense tracker is using? Add that to the comments below. Now I want to show an example using the OpenAI SDK. This is a financial research assistant created with Python. It takes user input, searches the internet for information, and organizes it for the user. It has voice translation capabilities as well. It follows the routing design workflow, but instead of me manually showing you, I'll let Cursor show you and run it as well. I'll write in, could you please explain the way that the financial research assistant works? So we have the main orchestrator acting as financial research manager. Core workflow steps are planned, searched, performed searches, writing reports, and verifying reports. After the manager starts the program, it goes to a planner agent, used to break down the user's query into specific search items. Each item contains a query and reason to search, then returns a financial search plan with multiple searches. That is passed to a search agent that does the searching and groups the results. Next is the analysis phase, using specialized agents for different aspects. The two agents in this phase are the financial agent that checks key metrics and risk agent that calls out red flags. Both agents give a summary to the report writing agent. The writer agent mixes the information together, combines search results with financial and risk analysis, then generates a structured report with markdown, a brief summary, and follow-up questions. That goes to the verify agent that checks the report for accuracy and completeness. It also has a voice interact agent to listen and answer questions about the report with audio. And finally, we get the output results. You can notice it uses the prompt chaining workflow to pass requests between agents before providing an output to the user. Now let's test this out. Let's run the financial research agent. So this is what an AI coding agent looks like at work. I can't lie, using Cursor, Windsurf, and AI agents in general has been a legit game changer for my overall workload ability. Okay, so looks like I need to install some dependencies, so I'll go ahead and do that now.
5 minutes later.
So I installed those dependencies and the server is up. Now let's start the financial research agent. What are the key financial metrics for Tesla? Okay, so it's searching now. Looking good so far. Let's review the output. Great. The financial research agent has successfully generated a comprehensive report about Tesla. Let's pull the report up here. I could read all of this, but this is a great time to test out the voice functionality. Okay, so run the voice functionality. Tell me about the key financial metrics mentioned in the report. So we can tell the voice function is working as expected as well. Finally, I'll show how we can translate the report into Spanish. Using the MCP tool allows us to translate the language to Spanish. You can see the results here. So that was an example of code implementation, and I'll be making a follow-up course soon with a guide on building these agents in more detail. Keep in mind there is a ton of ways to implement an AI agent. When choosing a method, always try to balance what makes sense for your needs with your level of understanding. Before I end this video, I want to take some time to break down the thought process of choosing an AI agent for your situation. Although some people are weirdos like me who love working on tech for fun, a lot of us are building agents that hopefully can be used in real-world situations. This can be personal life, business life, building a startup, or anything else. I recommend the Y Combinator channel for cool AI videos, startup, and things like that. A good way to determine what agent to build is to look in the mirror. What are you doing now that an agent could be doing for you to make your life easier? Don't even think about the build. Just fantasize about what will make your life easier if you didn't have to do it manually. For example, while working as a senior infrastructure engineer, I frequently need to submit ticket requests to a firewall team, network team, and load balancing team when changing enterprise networks. I thought of using AI agents to optimize my workflow and do the basic submissions that I could follow up on. Just use the prompt information I gave earlier to find the workflow that makes the most sense for the situation. But what if you just graduated and don't have a job to optimize? A good method can be acting as an intern of sorts to connect with a business. Then mine the mindset of your coworkers to find what speed bumps and roadblocks they experience that will be mitigated with AI agents. Usually the 9 to 5 can leave people with a mindset of, that's just how things work. With an innovative perspective, you'd be surprised how fast you can revolutionize a concept that an outsider wouldn't even be aware of. Once you go through this process, you will soon realize that this isolated solution is not as isolated as you thought and is replicatable to a wide range of other businesses as well. And boom, now you're laying the foundation for your potential future startup. Finally, another tip I found on YC is that for every software as a service company you see out there, a potential AI counterpart exists to be created. Bow. That is a direct path to at least start building your skill set and knowledge base. There is a ton of SaaS companies out there that you can potentially duplicate in some form. Imagine an AI version of that company and create it. Finally, I want to touch on the key AI innovations that have occurred recently. A major development in 2025 has been with audio generation and voice. Audio generation is getting crazy nowadays. Here's an example from Sesame that is honestly pretty unreal.
Hobbies to meet people, well, joining a club or online community can be really fun, especially if you're into gaming or crafting. Volunteering is also a great way to connect with awesome people who care about the same things as you.
There's also big developments in image models such as Rev, Gemini Flash, GPT-4o, and video models like Sora too. Basically, anything in the audio video space has a good chance to see big innovation in general. Okay, so now I'll wrap this up with some overall advice for those stepping into this field. There is a reason why I made this video about concepts and didn't focus on tutorials or minute detail. This industry is changing every day and it is easy to be overwhelmed. Don't be. With the knowledge in this video, you now have a solid foundation to confidently learn and grow with the technology. I've spent over a decade in the tech industry and worked on everything from missile systems, cybersecurity, network technologies, web design, and AI agents to name a few. The one consistent factor of technology is that it changes. If you keep your finger on the pulse and keep a positive mindset, those changes will eventually become an advantage. Know that you are good enough to create the next startup and change the world. Keep up with the innovations like Gemini 2.5 Pro recently released, for example, or MCP enabling better tools. Also, know when to ignore the overhyped news that comes up. Know the fundamentals are fundamental and everything else will be built upon them. Once you accept that and put in your best effort, you're more than on your way. Really appreciate you guys watching. Thank you so much, and I know your journey is just getting started. Till next time.